All right, so we've solved some quadratic equations by factoring, but maybe there's another method if we can't factor. So this first equation, we can factor this, but the first thing I'm going to do is set it equal to 0 and put it in standard form. So I'm going to attach a -9 to both sides. This would be x squared minus 9 equals 0. And then factoring, well, this is a difference of squares, so this factors to x plus 3 times x minus 3 equals 0. And if we take each factor equal to 0, we notice we're getting two answers. From x plus 3, we get x equals -3, or x equals +3. So if we solve this factor equal to 0 when x is 3. So we get our two answers. And if you plug them in, -3, the quantity squared is +9, and 3 is +9. So we're looking for all solutions. But what if, when we had this equation, we noticed that, well, I have x squared equals 9. What if I take the square root of both sides? So if two sides are equal, we should be able to set the square roots equal. And notice what we get. Well, the square root of x squared, well, that's a perfect square. That's just equal to x. And the square root of 9 is equal to 3. So you notice, I guess we're getting our answers, but we're missing one. So the square root of 9 is 3. It's called the principal square root. But when we're solving an equation, I want all values of x that make it true. So what we do is we just have to remind ourselves that plus or minus 3 will actually solve. So this is a symbol. This is new notation we use to symbolize plus or minus 3. So this is a +3 or -3. And it's just kind of a nice, simple way to do that. If we're doing a lot of things with solving square roots, we'll use the plus or minus 3 a lot. So the square root property says this. So say I got um, a perfect square. So I'm just going to generalize this like an a squared. So if a squared, that just represents a perfect square, equals some number, we'll just call it b, then a would equal plus or minus the square root of b. So we can take basically the square root of each side, um, and this is what the square root property is telling us. So let's look at this other example. And again, the key here is that the left side should be a perfect square, so that when I take the square root, I actually simplify it. So I'm looking for a perfect square term, or a perfect square expression. Um, so if you notice here, the next example, um, I'm going to try and solve x squared minus 18 equals 0. Well, I have a perfect square term, but it's not equal to 0. So all I need to do is add 18 to both sides, and I end up with x squared equals 18. So now I have a perfect square. So now I can apply the square root property. So I'm just going to call it SRP. And basically it allows me to take the square root of both sides. The left side is x, but the right side, I can't forget that it's actually plus or minus than the square root of 18. So our two answers are positive square root of 18 and negative. So since we know how to simplify, we always want to, if we have an expression of square root, we want to simplify. So the square root of 18 is the same as the square root of 9 times the square root of 2. So x then would equal plus or minus, the square root of 9 is 3, and then the square root of 2. So this would be the exact answers. That square root of 2 gives us our answers in exact form, right? But we know the square root of 2 is an irrational number. So we could approximate these answers. I'm just going to use the decimal calculator. Um, this would be 3 and then square root of 2. And the answer shows up here. And if we approximate, say, to 2 decimal places, that would be 4.24. So I'll bring it back. X, then we could say um, X is approximately equal to plus or minus 4.24. So again, we use approximation sign when we use decimals, but we're going to focus on the exact answers in representing those. So let's do this last one. Use the square root property to solve x plus 2 the quantity squared equals 9. So again, we have to recognize that the left side is actually a perfect square. So this is a perfect square factor. So the parentheses squared. So if I take and apply the square root property, the left side then would just become x plus 2. The right side, when I take the square root, would be plus or minus the square root of 9, which is 3. So when I take the square root of the right, I get 3. It comes out perfect. So how do I solve this? I still need to solve for x. So I'm going to leave the plus or minus notation and just isolate x on the left side by subtracting 2 or attaching a negative 2 to both sides. Now, again, it's weird. I can't, on the right side, what am I attaching negative 2 to? So it's either a positive 3 or negative 3. So what we do is we just keep the negative 2 apart from the plus or minus 3. And then we can take and look at each um, expression um, separately. So we have x equals negative 2 plus 3. So that means x equals 1. Or x equals negative 2 minus 3, which is negative 5. So again, we're just going to work with this plus or minus term as a term, solve for x first, and then split it up to find our values. All right, in the next section, we'll go through some more simplifying, some more equations to solve with the square root property that are a little more complicated, but we're going to be working with the plus or minus expression or that term as we solve.